elimination. Let's keep going with this. It's just going to show some different ways to do elimination. And again, we've already talked about a lot of them, so it's just a matter of getting comfortable with what's going on here. So hopefully we'll be okay with that. Again, tying it into word problems, which is so important. So how many sets of dragonfly wings and fairy wings did Phoebe's moms purchase? I'll read the question in a second, or at least the setup in a second, but I want to know what I'm solving for. So the number of dragonfly wings, and you can see how sort of the more you do this, the easier it should become. And we'll call it F, the number of fairy wings, just following that process of defining the variables or making a let statements, writing the equation, and then solving them. It's just a question of how you want to solve them, equal value, substitution, or elimination. Okay, so Phoebe was helping her mom buy party favors for her little sister. There's 11 friends attending the party. We'll get to that in a second because that one's a little bit tricky. So costume dragonfly wings cost $1. So 1D or D plus 2 fairy wings cost $2. And she spent $18. So what's the second equation? And this is an often overlooked one. There's 11 friends, and each of them are either going to get a dragonfly or a fairy wing. So D plus F equals 11. I call this the number of equation, and a lot of kids really struggle with that number of because it's so easy to forget. So we know this is the money equation, right? But this number of is really important. We want to make sure we have that. So we'll go ahead and set these two things up. As a matter of fact, I'll just slide this one underneath. So we have D plus F equals 11. I'll kind of clear this out of the way to give myself some room here. And I can go ahead and do some elimination here, but it would be easier if I multiplied the bottom one by a negative. So I'll create myself some room. The top is going to stay the same. D plus 2F equals 18. But the bottom I'm going to, again, distribute. I get negative D minus F equals negative 11. Again, we did the elimination 631, so this is a continuation. We've eliminated the D's, so we get F equals 7. So if there's 7 fairy wings, there must be 4, right? 4 plus 7. There must be 4 dragonfly wings. And then we'll kind of do the math on this. $4 plus 2 times 7 is 14, so 4 plus 14 is 18. Works out perfectly. $18 spent and 11 total costumes, so we're good on this one here. We will keep working. So, oh, I opened the wrong one. My mistake. Let's see if I can immediately go to 632. So, it rarely works. Yeah, so I'm going to have to close this. Darn it. And open 632 again. So 632A. Working with more elimination. Now we're on to 691. Said Rachel is trying to solve this system. And again, combining the equations, you can see nothing eliminates. If you add these together, you get 5x minus y equals 11. We have to have something that eliminates. So again, sort of just jumping through what the book is trying to tell us and just going straight to the chase here. I can't eliminate anything here. The question is, do you want to get rid of the x's or the y's? And it doesn't matter. You can get rid of either one, but I think it's going to be easier if I just multiply the top by 2. I'll get 4x plus 2y equals 20 and leave the bottom the same. I'll get 3x minus 2y equals 1. And I'll add them together. I get 7x equals 21, so x is 3. And again, that's not enough. I need an ordered pair. So I have the x part of the ordered pair, but now I need the y. So 2 times 3 plus y equals 10. 6 plus y equals 10. So obviously y is 4. But again, I can't assume that I'm correct, so I'm going to plug in the last one. 3 times 3 minus 2 times 4 should equal 1. And 9 minus 8 does equal 1. So I feel really confident with that 3, 4. And again, I think the book is probably telling us that that's what we need to do. I just was, I guess, impatient and jumped straight through it since we've already done elimination a couple of times. So it sort of talks us through that. So let's go ahead and go down to 692 and solve this word problem again, same way we always do. We're going to write a system of equations and define the variables, etc. So 21 animals on the farm, all sheep and chickens. If the animals have 56 legs, how many each type of animal lives on the farm? So that's what we're looking for. We'll make S equal the number of sheep, and we will make C equal the number of chicken. We have two equations that we need to write. So they have 56 legs. Well, sheep typically have 4 legs. Chickens typically have 2, and that's 56 legs. The other question is, what's the other equation? Well, again, the number of, right? There's 21. So if I add up all the sheep and all the chickens, I get 21 animals. At this point, we need to eliminate here. I think a lot of you would probably just multiply the bottom by -2, which is great. I just want to show, what if you had multiplied the bottom by -4 instead, and instead eliminated the s's? It works the exact same. Again, I just want to make it clear there's an infinity of ways to do this. So if you choose a way that a book or a worksheet doesn't choose, it doesn't mean that there's a problem. It's completely acceptable. So in this one, we'll get -28 divided by -2. So C is going to equal 14. So there's 14 chickens, which means there must be 7 sheep, right? 7 plus 14. And now we should double check that. So 4 times 7 is 28 sheep legs. 2 times 14 is 28 chicken legs for 56 total legs. So that makes sense. So we're pretty pleased with that. We will go ahead, keep working on this. So we are down to 693. While Brendan is vacationing with his family at the cabin, they take a motorboat on the river. The motorboat travels 18 miles per hour in still water. Okay, so this problem is definitely worth paying attention to. This is going to be something we haven't quite really seen yet, which can be a little bit tricky if you let it be, for sure. So it's a distance equals rate times time problem. We did see a little bit of it earlier, but not by too much. So Brendan's vacationing with his family at the cabin. They take the motorboat on the river. The motorboat travels 18 miles per hour in still water. Let W equal the speed of the river current in miles per hour. So write an expression for how fast the motorboat is able to go downstream with the current. Well, it goes 18 miles per hour plus the current will move it. That's if it goes downstream. Well, what if it goes upstream? If it goes upstream, it's fighting the current. So 18 and whatever the current is, it will go less than that. Now, this ignores, I think, a lot of science as far as drag and wind resistance and all that other stuff, but whatever. This is how we are asked to solve these things, and just assume that the current, if we go with the current, it adds to how fast we're already going, and if we're going against the current, it subtracts from how fast we're already going. So the motorboat travels 49 miles upstream in the same time it takes to travel 77 miles downstream. What is the speed of the current? Use the elimination to solve this. So we have distance equals rate times time, right? So the distance is going to be the same either way. Oh, wait a minute. No, I guess it's not the same either way. So the time is going to be the same either way. So here, 49 miles upstream equals 18 minus W, because that's the motorboat travels 49 miles upstream, so times however long that is, and the same time that it takes 77 to go 18 plus WT, right? This is my distance, this is my rate, this is my time. They gave me the distances. We already figured out the rates, but the time is going to be the same for either. So my suggestion would be this. I would distribute the T, and I would get 49 equals 18T minus WT, and I would get 77 equals 18T plus WT. And now when I eliminate, these are going to eliminate, and I'm going to be left with 36T here, and what, 126. So I'll divide both sides by 36. So let's see what 126 divided by 36 is. So we get 3.5. So T equals 3.5 hours. So the question is, what is going to be the the W, right? So if I plug in 3.5 for T, we'll get 49 equals 18 minus W times 3.5. I'll distribute, I don't need that, last parenthesis, I'll distribute. So I get 49 equals, what's 18 times 3.5? And this problem's a little bit trickier because it's distance equals rate times time, right? So we get 630 minus 3.5 W. We'll subtract 630 from each side. So we're going to get 49 minus 630 is negative 581. So negative 581 equals negative 3.5 W. Obviously, we'll divide both sides by negative 3.5. And we will see that W equals 166. 166. I gotta be honest with you, that seems highly unlikely that I'm right here. This is gonna be unfortunate. I have to redo the whole video. I'm not sure if I screwed something up or what, but oh, 18 times 3.5 is definitely not. Yeah, I did 18 times 35. That should be 63. Sorry. So this is 63. So that's minus 14. Ay, ay, ay. Man, oh man, I missed a decimal. How frustrating is that? So I'm going to go back up here. I apologize again. I'll make another comment that I screwed up again. But I would rather do that than make this entire video again. Oh man, that annoys me. Okay, so we are going to go back here. This is 63, so minus, is that what it was? 63? Yeah, 3.5. So minus 63, so I'm going to get minus 14 equals minus 3.5 W. This makes way more sense. Divide by minus 3.5, and 4 is going to equal W. So that's the current, right? W was the current. So 4 miles per hour. And now if I go back over to the other equation, which was the 77, so 77 equals 18 plus 4 times T, which was 3.5, we should get 77. So 77 equals 22 times 3.5, and 22 times 3.5 hopefully equals 77. So there you go. So that worked out fine. So the current's 4 miles per hour, and the time is 3.5 hours. I think there's a way better way to do this one that I forget all the time that other kids always figure out. But sorry I screwed up there. That should have been a decimal. I know there's a lot to this problem. This is not a super easy problem. Maybe rewind it and watch it again. Alrighty. And then to finish up this lesson, 632B, I believe. It says for each system, determine, I think we already did these two problems, right? That's the, yeah, okay. So for each system below, determine the best way to solve it, if we think it should be elimination or substitution or what we think. So again, this is kind of what I was trying to talk about. Don't fall into the trap of only doing substitution or only doing elimination. It really should be a problem by problem decision. This one sets up perfectly for elimination, right? If I multiply the bottom by -1, I'm going to get 5m plus 2n equals -10 on top. On bottom, I'll get -3m minus 2n equals +2. So these will eliminate. I will get 2m equals -8, so m is -4. And then if I substitute that into the top, 5 times -4 plus 2n equals -10. -20 plus 2n equals -10. Add 20 to both sides, I will get 2n equals 10, n equals 5. And then finally, if I substitute it into here, 3 times -4 is -12. 2 times 5 is 10. And that should equal -2, and it does. So I think elimination was the way to go for the first one. Second one, I guess these are all set up for elimination. I guess I was tricking myself. But long story short, the A's and B's don't line up. So I'll say 6A minus B equals 3. This I'll move it around to 4A plus B equals 17. The B's will eliminate. I will get 10A equals 20. So A equals 2. I'll go up here and sub in 6 times 2 minus B equals 3. So 12 minus B equals 3. Minus B equals minus 9, so B equals 9. And then finally I'll go here, B equals 9, plus 4 times 2 is 8. 9 plus 8 equals 17, so pretty pleased with my answer there. And finally, I think if I multiplied the bottom by 2 and get rid of the y's, that would be the easiest. So the top, 7x plus 4y equals 17. The bottom, 6x minus 4y equals negative 30. The y's will eliminate. I will get 13x equals negative 13. Divide by 13. X equals negative 1. If I sub it into the top one, 7 times negative 1 plus 4y equals 17. Negative 7 plus 4y equals 17. Add 7, I get 4y equals 24. Divide by 4, y equals 6. And if I sub in here, 3 times negative 1 is negative 3. Negative 2 times 6 is negative 12, and negative 3 minus 12 should equal negative 15, and it does, so that's a 6, by the way. A 6. So again, sorry so sloppy, and I do go through these fairly quickly just because you can rewind them and look at them again, so hopefully we're good with that.